Welcome to Lesson 35. In this lesson, we will look at the design of groove welds. The design of complete joint penetration, or CJP, groove welds is relatively simple since the effective area of the weld, uppercase A sub W, is equal to the full cross-sectional area of the base metal. For CJP groove welds, subject to tension, such as what you have in a butt splice, the strength of the weld metal need only match the strength of the base metal. The strength of the connection is controlled by gross section yielding of the base metal. No explicit design of the weld is required. If plates of different areas are joined, the design strength of the splice is controlled by the plate with the smaller cross-sectional area. For partial joint penetration groove welds, the effective area of the weld is the effective throat times the length of the weld. The effective throat is a function of the total angle of the groove weld. If the angle is less than 60 degrees, the electrode will arc above the root and not penetrate the full depth of the groove. The effective throat is reduced by 1/8 of an inch. Note that the angle cannot be less than 45 degrees. If it is, the groove is too narrow to make the proper groove weld. When partial joint penetration groove welds are designed for tension, perpendicular or normal to the effective area of the weld, the design strength of the weld is given as 0.6 times the tensile strength of the weld metal times the effective area of the weld, and then reduced by a reduction factor of 0.80. Note that failure of the weld is assumed to be shear even though the force is tensile. The base metal must also be checked. The design strength is given as the tensile strength of the base metal times the effective area of the weld reduced by a resistance factor of 0.75. When a partial joint penetration weld is subjected to compression to the plane of the weld, no design needs to be performed on the weld metal. However, the base metal needs to be checked as shown. Shown in this slide are provisions used to design partial joint penetration welds subjected to shear. Fabricators cannot just weld anything they want. They must qualify their welding procedures first. The welding procedure involves welding a complete joint penetration groove weld test plate specimen. The specimen is then destructively tested to determine the strength and quality of the weld. The parameters of the welding procedure include electrode strength and type, base metal strength, welding process, SAW for example, heat input, which includes current and travel speed. Before a welded detail can be used in constructional steel, it also must be qualified. This also requires expensive destructive testing. The American Welding Society, document D1.1, provides provisions for welded joints that are pre-qualified. This means that the fabricator can use these joints with a pre-qualified procedure and not have to do any additional testing to ensure weld joint strength and soundness. Limits on joint geometries, such as root openings, angles, clearances, are given and are based on a long history of successful use and performance of these joints. Use of pre-qualified joints still requires the application of sound engineering judgment, however. Part 8 of the AISC Steel Manual provides a series of pre-qualified welded joints. By being pre-qualified, it means that these joints can be used without any further testing. Joints that do not conform to specified dimensions must be qualified by destructive testing, which becomes expensive. Typically, when designing welded connections, engineers should not specify the joint other than determine the type of joint, CJP or PJP, and effective depth. Let the fabricator decide on the specifics of the joint. This ends Lesson 35 and Module 15.